We're going to use the root test to determine whether this series is convergent or divergent. So we're going to take the limit as n approaches infinity of the nth root of the absolute value of a sub n. And if this equals 1, then it's inconclusive. It's inconclusive. If this is greater than 1, it diverges. If this is less than 1, then it absolutely converges, which means that it also converges. So now let's try to find out what our absolute value of a sub n is. So the absolute value of our a sub n would be this. A natural log of n to the power of n. And this is the same thing as having 1 over the natural log of n. That's because no matter what you plug in here, you're always going to get either -1 or 1. But since we're taking the absolute value of it, it's just going to be the positive 1. And this is natural log of n, to the n. But now we can bring out the power. We can bring out the power because, remember, 1 to the power of anything is just n. 1 to the power of n, which is 1 to the power of anything, is going to give you 1. So this is this. And we're taking the limit as n approaches infinity of this, and we're taking the nth root by the root test. So what we did was we just found what the absolute value of a sub n is. Now we could actually do the rest of this part. We do the nth root, and we take the limit as n approaches infinity. The nth root makes the exponent of n go away. And now we can plug infinity into this n. So that's going to give us infinity in the denominator, because remember that the natural log looks something like this. And so it just keeps growing and growing and growing. It does go up forever. So we have an infinite denominator. 1 divided by infinity is 0. And 0 is less than 1. So this absolutely converges by that. It absolutely converges by the root test.